Hello and welcome everybody. Thank you for joining us today for our Parallelization Work Data Management Using Producer Consumer Automation webinar. My name is Tim and I'm a technical account manager at Robocorp, and I'm joined by two of my colleagues today, Blake and Eric. They'll be helping to answer any questions that come through in chat and jumping in during Q&A. For our participants on the call today, we have everyone muted. If you have any questions, please put them in chat and we'll try to answer them as we go or during the Q&A portion. So now one of the reasons that everyone's here is to understand what are the benefits of producer consumer bots. So let's jump right into the benefits. And the first one I want to talk about is running bots in parallel. So the really nice thing about this is that we've brought cloud elasticity to an RPA solution. So this means that you can bring up environments on demand and there's no more of buying spare capacity. So this is really nice for things like periodic or seasonal use cases, things like high volume or time sensitive use cases such as SLAs. Another of the benefits I want to discuss is the rerunning of only the failed items. So if you have 100 work items and only one of them fails, you don't have to back everything out and rerun the entire set. You don't have to try to rerun it again and hope you don't get duplicates. You can just correct the data for that one work item and rerun just that one item. And the other really nice thing is that, and I know we say it's business and user ops focused, I think it's also a little bit dev focused here because you get a really great opportunity to get custom error messages. So as a dev, you can be very clear and concise in what you need the business ops user to do in order to correct that one work item. And as a business user, when you log into Control Room and you see your failed items, you have the opportunity to have a very clear message in what needs to be corrected in order to rerun it. So some really nice benefits to using the producer consumer model that I really like. Now, all of that is great in theory, but how about the real world example? So we had a customer a while back who was using our producer consumer bots in our work data management, and they had 57,000 patient records that they needed to update. So they spun that up across 10 parallel environments, and it took them about 6 days to run. Now, normally that would have taken about 61 days in a single linear bot. A couple days later, their client came back to them and said, we didn't actually need 57,000 records updated. We only needed 4,000 records updated. So they went ahead and made some code corrections and they reran their code on 20 parallel executions this time instead of 10. And they completed the fixing of all 53,000 of those patient records in about 2.5 days. So again, with work data management and with producer consumer bots, you can have some real world significant impacts. And this is a great example of how that works in the real world. So let's talk a little bit more about the producer consumer framework. So when we say producer consumer, what we're talking about is the framework of your bot structure. So producer consumer will always have at least two .robot files, one producer and one consumer. So when we talk about the producer side of the bot, what we're talking about is something that creates the work items and passes those to the consumer bot. So on the slide that I have in front of me, we have an example where we have an Excel as our data source, and we're taking that Excel data and we're converting it into work items, in this case, 4 work order work items. So from the producer side, those work items are then sent over to the consumer side. And the consumer bot in this case is going to take those work items and it's going to figure out what to do with those work items. And then it's going to mark them as completed or failed. And we'll get into that a little bit later. But it's the consumer side that's going to work with the orchestrator. And in this particular example, in this particular image here, the orchestrator has 3 execution environments that it has available. So what that means is that when those 4 work items get sent to the orchestrator, it's going to then take each of those work items and pass one work item to every available execution environment. Once that execution environment completes that work item, the orchestrator is going to hand another work item to it until all work items are completed. So that's how our producer consumer is working. Now, how do we get started on this? And actually, let me go back to the slide. I apologize. I want to talk about one other thing here, is that In today's example, we're going to be talking about a producer bot and a consumer bot, but know that there are some advanced use cases where you don't have to have the producer bot. You could just have the consumer bot. For example, if you passed in the work items through an email body and some other things like that, there are ways to do it. Check out our docs pages for additional information on how to use some of the more advanced use cases. But for today's webinar, we are going to focus on the producer and the consumer bots. Now, how do we get started with our producer consumer bots? And the first way and the easiest way to do this is really through the producer consumer template. So if you already know that you want to leverage a producer consumer bot, then the fastest way is to jump over to your workspace. And when you're in your workspace, use the Command-Shift-P in Mac or Control-Shift-P in Windows and select the Create Robot command. And that'll bring up this next menu where you can select your template. And the third one down is the producer consumer model template. And this is the one that you want to leverage. And what this is going to do for you is it's going to go ahead and create a producer.robot file and a consumer.robot file, along with the necessary updates in the robot.yaml file. So you can get started straight away using this. Now, this is not the only way to do it. You can also convert a bot. So if you've been running a bot in production for a little while and you are now having higher volumes and you need faster processing times, then you can also convert your bot from a standard template into a producer consumer template. And that's what we're going to be doing on today's webinar. If you were with us in our April webinar where we talked about Python and Robocorp, then we're going to take that bot and we're going to convert that into a producer consumer bot today. Now, producer consumer, like all the things that we're doing here at Robocorp, can be coded and supported in both Robot Framework as well as in Python. So language of choice, whichever you're more comfortable with. The other thing about producer consumer is that you can also kick this off like all the other bots that you have. You can kick it off through API, scheduling manually, or through the rpa.robocorp.process library. With the work items for a producer consumer bot, you also have multiple input methods. So you can ingest your work items through a database, through Excel, which is what we're going to be doing on today's example. You can add it through strings, anything serializable really. And the last thing that I'll mention about the work items is that you can also include files in the work items. You don't just have to put string and data into the work items. You can also attach files to it. So like I mentioned, if you were here in our April webinar, this process flow will look pretty familiar to you. This is something that we're modifying for today. So this is the new structure of today's flow. It's just a sample business process. And so what we have here is we're going from AWS, we're taking an Excel file out, we're extracting some data out of that Excel, we're going to Salesforce, extracting some data out of Salesforce, going to Google, doing some Google Maps stuff there, taking a screenshot, reloading that into the case notes for Salesforce, and then messaging through Teams to let everyone know that we have completed and updated that particular case. So I've gone ahead and split this flow into what I'm going to need for the producer bot, which is the AWS and the Excel steps, and into the consumer bot steps, which involves Salesforce, Google, and Teams. So that's what we're going to be doing, and I'll show you the original code into the updated code when we get into that here in just a little bit. Now, what I also have here, and these are the important things that I just want to highlight for producer consumer, is this work data management checklist. So up until this point, I've been talking about producer consumer, and I talked about that's a framework and how you kind of structure your bots. But I'm now using the term work data management. And so I just want to define these terms really quickly for you, but know that I will use them interchangeably and I really mean the same thing when I do. So just as a way of definition, producer consumer is just a framework. It's a way to structure your bots. And when we talk about work data management, we're really talking about the library and the behind the scenes mechanics that allows the parallelization to happen. So on this slide, there are 3 keywords for the producer and 3 keywords for the consumer side that you need to keep in mind when you are coding this, because those 3 keywords are necessary in order to be successful. So on the producer side, you need to create your output work items. You need to set work item variables, and that really just creates content into the shell that is your work item. and then save that work item, because work items are ephemeral until you actually save them. In the consumer side, you need to make sure that you do something with each of those work items that's passed in, and that's what the for each work item keyword is. It tells your logic kind of what is the thing you're going to do with each work item. You need to get work item variables, and that allows you to take out the content of that work item that you set in the producer side, and it allows you to create it as a local variable so you can leverage it inside your .robot file better. And then lastly, you need to release the input work items, which is either done or failed. And if you mark it as failed, that's where you get a chance to mark those detail failured messages. Now, on the producer side, you'll see here I have a note where I talk about the fact that you can either do all three of those keywords independently, or you can do those three steps in one keyword in the create output work item keyword. Now, when we get into the actual code here in just a second, I will show you examples where you can do it as single or as all three keywords. There's not a right or a wrong. It's whatever you're more comfortable with or whatever the situation for you in your code makes more sense. So this is the checklist that I'm gonna kind of walk through here when I look at the code. We're going to talk about the producer side and then the consumer side, and then we're going to talk about the robot.yaml file. So if we go ahead and jump over into the original code here, then this should look familiar if you were with our last webinar. So we have everything in a single .robot file here, and everything is just linearly going through, and once it hits a new case, it'll just repeat and repeat and repeat until everything is completed. So if we wanted to make that into a producer consumer bot, then what we're going to need to do is we're going to need to create two different .robot files, the producer tasks.robot you see here, and the consumer tasks.robot that you see there. Now, in the producer side, I've gone ahead and extracted everything that isn't necessary, or I've taken out everything necessary, excuse me, from the consumer side. So it's just the AWS and the Excel steps in here. And then this is where all of the magic happens as far as the work items themselves are concerned. So in the producer side, you'll remember we need to create the work items. And so these two keywords are identical. They're just they're semantically a little bit different. And so this is where you need to create the output work item. And in this particular keyword here, and I'll focus on this one for just a second, this is where it initially creates an empty shell of the work item. We then set the work item variable below it. And so this is just a key value pair that we're setting here. And that fills in the content into the work item, gives it some body. And then we save the work item to make sure that all the changes that we've made previously are saved and the work item is updated. So this is really the key and the unique aspect of the producer side, is creating these work items. Now, I mentioned on a couple slides ago that you could also do it as a single work item, or say as a single line for creating the output work item. And that's what I've done here in this keyword. So I'm still looping through my cases, and I'm still taking each case number and creating that as my variable inside of my work item. But initially, I'm just creating this as a dictionary, and then creating this dictionary variable. And then I create my output work item. So I create my empty shell. And then my variables argument sets the body of my work item, or sets my variables. And that's what I'm assigning the dictionary here to. And then I save equals true. So I'm just saving those work items. So you can see here I have a one-to-one creating the output work items, setting my variables, and then saving. So different semantically, but they do the exact same thing for code. Now, so that's the key aspects of my producer bot. Now, in my consumer tasks.robot file, what I've done is I've stripped out all of the producer steps, so I don't have any of those. And in my consumer side, you'll remember we had three things we needed to do. And the first of those three was that we needed to, for each input work item, we needed to leverage that keyword. And that's the first keyword you're going to want to leverage, because that tells the code what to do with each work item when it's given to it. So in this case, I have one keyword here, which handles all of my logic for each of the work items. And I won't get into all of the steps in what I'm doing here. All of this code is on GitHub, so you can look through this all yourself. And if you have any questions, you're always welcome to ask us on Slack. But what I'll talk about here is just this particular line inside of my initial logic. So I have my for each input work item, and this is the keyword I'm calling. Inside of that keyword, I'm getting my work item variable. So I set this case number variable in my producer side. Now I need to extract that value and leverage it inside of this bot. So I do that with my get work item variable. I define what it is I'm trying to extract, which variable I want, and then I set that to a local variable so that I can leverage it inside of this .robot file. So I've done the first of my two keywords on the consumer side, and the last thing I need to do is I need to release the work items. So you can do that with this release input work item keyword. Now, if you release an input work item successfully, then it's very simple. You just mark it as release input work item and done, and that's all you have to do. It's marked as successfully completed, and there's nothing else you need to talk about. Now, the other things that you can do is there are also a couple of failure messages that you as the user can prescribe. So you'll notice here that I have an application failure type and a business failure type. So there are 4 failure types that you can have for a work item. The first one that we'll talk about is the business failure type. And so this indicates that something happened where it's a failure, but it's something that is probably related to something the business user can correct. It's generally data you can update inside of the JSON or some kind of system, and you can generally rerun the work item and make it, and it'll be successful. So this is something you as the developer define what type of failure it is, business or application. In this case, I have a business. I've given it a code, and I have a custom error message. So I'm just letting the user know that this particular address is invalid. I need them to correct it inside of Salesforce and then rerun this particular work item once Salesforce has been updated, because that's my source of truth. I don't want them to just update it in my in the local setting. I want to update the source of truth. And I'll talk about how to update and correct failures here in a little bit, but this is how you set those failure messages. So that's the business type failure. The next one I'll talk about is the application type failure. And generally, you're going to leverage an application type failure if it's something that happened in the application. So for example, if an application went down and has sent you a timeout message, if an application is in the middle of an update and has sent that kind of error code, you can capture those error codes and you can identify them as application errors. And then how you handle those is really up to you as a business. You can rerun those just the same way you would a business, or you can, make some corrections on the application side and try to rerun after that. So those are the 2 that are user defined. There are 2 others that you might see. And the first one you might see is orchestrator, which means something happened on the orchestration side. And that's something you're going to have to rerun and try again, or you'll have to, ask us on Slack, and we may have to help you look into it. The last message type that you're going to see is unspecified as a failure type for the work item. And that just means that something happened that the system doesn't know what type of failure it should have been. So in that particular case, you need to investigate and understand a little bit more about why it failed to determine how to fix that particular issue. So that's how you mark all of your work items as done or failed. So now in our producer side, just to recap, we have created our work items, set a body to it, and saved them. In our consumer side, we've determined what logic we want to do for each of our work items. We have extracted the variables out of our work item, and we have marked them as done or failed. So now that we've done that, we also need to update our robot.yaml. So what you'll see here, and these are the 2 lines, or these are the few lines I should say that really matter here, is the robot.yaml needs to have 2 tasks. And it needs to have one task for the producer side and another task for the consumer side. And you'll see that's what I have here. So I've got a task named producer tasks, and that comes with this particular execution command here, and you'll notice that it's calling the producer-tasks.robot file. I also have my consumer tasks defined, and I have my execution command as the consumer-tasks.robot file here. Now, each of these tasks, when you get into control room, when you're creating your process, those will end up being steps inside of your robot. So the reason it's important to have different tasks for producer and consumer is because those end up being different steps inside of your robot inside of the control room. And I'll show you that when we get into the control room side. So those are all of the steps that we're going to need to do in order to convert from our standard robot file to our producer consumer style robot. And so just to recap what we've already talked about, how to create the producer steps and how to create the necessary producer keywords and then the necessary consumer keywords. So in our control room, and let me go ahead and bring this up. So in our control room, we had talked about the steps that are necessary. So I'm here in my in this example that we were just looking at, the code. So inside of here, you'll notice I have two steps: a producer tasks, which was the task we had just seen in our robot.yaml, and we have our consumer tasks. And so step 1 is the producer, and step 2 is the consumer tasks. So this is how you're going to need to set up whenever you create a new robot in control room. You'll have to make sure there's 2 steps: producer and then consumer. So now that we've done all that, let's go ahead and kick this off and let's go ahead and see how this runs. So what I've done here is I have got 4 different execution environments, and each of those execution environments is in here. So you'll see I have multiple, but I've created an environment group here. And in that environment group, I have these 4 execution environments. And so that's what I have set up here. So if I look at my structure, I've got my producer steps here, my consumer steps here. My producer steps are running in my cloud environment, and my consumer steps are running on this execution group. And so that group contains those 4 environments that you saw. So I'm going to go ahead and run this and kick this off. And so what you're going to see here is you're going to see my producer side with just 1 environment, and it's going to go ahead and pick it up, and it's going to create all of my work items, and then it's going to send those work items as individual items. So you're going to see 100 eventually pop up over here in pending, because that's how many work items I'm producing. And then it will slowly, one by one, ingest each of those up to the number of execution environments I have. And so what I've chosen to do is use 4 execution environments. And so I'm going to go ahead and let this run in the background. We'll keep jumping back and forth between a few things. But while I let this run in the background, it'll take about 10 minutes to complete. We'll go ahead and jump into any Q&A that there possibly is. And just see we'll go back and forth between Q&A and looking at this while this runs in the background for us. So I'll go ahead and ask Blake and Eric, are there any questions in Q&A for us?
Yeah, thanks, Tim. Yeah, we do have a question regarding those failures we talked about.
Okay.
So perhaps you can, while this is running, if you have a demo, I know that we often have a demo that shows how to correct failures.
Yeah, let me do that here. So let me go ahead and let's see if I can resize this window appropriately. There we go. We can also see here it's gone ahead and kicked us off. So hopefully we'll see some stuff pop up here while we're doing this. So what we have here is if I jump into a different robot that I have, jump into here. So I ran this earlier just to make sure we had a failure already ready for everyone. So when you've run your bot, you're going to get your failed items here, and it'll show on kind of the main dashboard. And so when you click on that failed item, it's going to bring you to this Work Data Explorer view. And so when you're here, what you can do is you can see that I have a business type failure. You can see that this is the data that was sent to this particular work item. And then the other thing is, and what you're not seeing right now is the failure message. So in order to get the failure message to come up, hover over the customized columns, and then go down to exception message. And you can also select exception code. I just know that exception code is blank for this particular example, so I'm not going to select it for you. And so the failure message here, if I hover over it, is the order process failed for Sol Heaton. So in order to rerun this particular, or to correct this failure, I can click on the work data here, and that's going to bring up a new side panel for me. And if I look, I have my key value pairs of what this work item is. So in this particular case, if I scroll all the way to the right, I can see that there's a misspelling on 1Z for this particular order, which is probably the reason for the failure. Now, I can correct it here, or if I want to, I can also look at this as JSON data if it's easier for me to understand or read. But I'm going to go ahead and update it here in this particular view. So if I go ahead and correct this, if I correct the spelling of 1Z properly, I can go ahead and click Update. And then when I close this, I can select this work item and I can click Retry One Failed Item. And so what that's going to do is it's going to kick off just that one item. And you'll see it's back in process here. And then in just a second, it should complete and we should see it go to done. And so we will have no more failure. So that's how you would correct a work item if you were correcting it just through control room.
Mm-hmm. You
Let's
know
go ahead. Sorry,
before
go
you
ahead.
keep going, you can show that, but that kind of highlights a very important design principle that I think all of our users should definitely keep in mind. Make sure when you're building bots that you're building bots in kind of an atomic fashion so that as failures happen, you can catch an error that's just that one piece and the rest of your process can continue, right? So you want to capture just the pieces that are failing so they can be reran with correction versus a monolith process of thousands of different things happening all in one big long bot, and then it fails and you're like, oh, well, now I got to rerun the whole thing. It'll take an hour. Well, I mean, if you had broken that up into a bunch of smaller processes that are each 5 minutes long, you're going to save a lot of time.
Yeah, great point. So everyone can see on screen, I'll just talk about what's happening on screen here. You can see popping up on each of these different environments, all of the different work items. So each of these work items is an address. And what we're doing is we're sending that address to Google Maps to search for it, to find it, and then to screenshot, and then we're going to attach that screenshot to Salesforce. So what you're seeing here is all of those addresses being sent to Google Maps. Each of those is a work item. So you're seeing our 4 environments running those work items in parallel. So that's what you're seeing on screen here.
Speaking of parallels, can we we had a question regarding the concurrency. Like, how do you tell a control room how many of these you've got and how many you want it to run on?
Yeah, that's a great point. I should have brought that up earlier. So thanks for whoever asked that question. So inside of your process, so you've created your workforce, you've created your new process, and you've added steps 1 and you've added step 2. So if you've gone ahead and done step 1, you've added step 2. So for your consumer tasks, what you want to do is click this Show Advanced button at the bottom and scroll all the way down. And what you're going to see here is a concurrency limit. So if you click the edit icon here, or this edit pencil, you can update that concurrency limit to whatever is necessary for you. I believe we have a default concurrency for a free tier, excuse me, there's a concurrency limit of 1. On some of our paid tiers, I believe the default concurrency is 10. If you need something higher, reach out to your either sales rep or to your customer success, and we can help you increase that limit. We can work with you on that. But 10, I believe, should be the default concurrency limit for any of our paid tiers. But that's how you would do it. Just click that pencil and change your number and click the save and you're good.
Yeah, and an important point there is that in the cloud, you're limited to the limit we have that it's configured for you, right? You don't have to do anything else because the cloud will spin them up for you.
Yeah.
If you're using the VMs like Tim is doing with those four images, then you're gonna need to have the VMs existent in order to have a concurrency more than the number of VMs you've configured, right? So like if you've got 4 VMs, your concurrency can't go higher than 4. I mean, you can set it higher than 4, just won't, do anything.
Yeah, there's nothing to send it to. And that's actually a really good point that you bring up when it comes to VMs. And so I want to talk about another client that we have when it comes to VMs and when it comes to costs. So generally, when it comes to running things in parallel, usually your cost is the servers themselves. And so what we've had a client do is they have a really, really powerful server. And what they've done on that server is they've actually created multiple users. So it's not one server running one bot, which I know is kind of the typical model a lot of people have, is one server, one bot. And so what you can do with the work data management with our parallelization is you can have one virtual machine, and you can have as many users as necessary on that machine to max out its hardware. And so when one of our clients has, I believe at this point, 28 users across, is it, I can't remember if it's per machine or if it's across 4 machines, but they have at least 7 users per machine. And I think they're increasing that number currently because they're not maxing their hardware out. But each of these users is an execution environment. So it's not a VM that's an execution environment, it's a user on the VM that's an execution environment. And so that's what I have here. So for example, RDP Jack, which is this top left, and RDP Jill, this top right, these are both 2 different users on the same VM. And I have a separate VM, which is Tan and Tammy here. And these 2 users are on a separate VM. So I have 2 VMs and 2 users per VM, which gives me 4 execution environments. So just realize that you can really max out your hardware and do some really cool stuff with the way that we've set up parallelization.
Right. That just requires the RDP configuration, which is slightly more technical than just installing Workforce Agent. But it's certainly, you can get over that hump, and obviously we're here to help. So let's see.
And Tim, just to update you on the numbers, it's actually 8 users per machine. So they have 32 complete users over 4 machines. And actually, we just looked at the data this morning, and it's still well under 50% CPU capacity, and the disk isn't really even being affected that hard for that. So the point of that is you can really push the username virtual machine concept pretty hard, and still have plenty of room to add more stuff to it. The other thing with that also is, remember to point out, that's not a license. Like, we don't charge per robot per license or anything like that. As long as you can put more and more out there, do it to it, right?
Yep.
Yeah,
that was
great
actually
point.
a question. Mm-hmm.
Yeah, no licensing costs for all the individual, VMs, like Eric said. So a really nice feature there.
Yeah, and actually continuing that theme, it's a much more advanced feature, but it is possible to build your own cluster as well if you want to build a dynamic cluster for yourself rather than use our cloud. So we do publish the kind of a bare bones Terraform that you can use to get that set up, and so you would theoretically be able to host your own cloud. Not cloud as in like our control room, but the execution cloud.
Yeah, great point. Yeah, there are some really cool advanced things you can do. So as we just saw here, and I think it took about, 10 minutes, maybe a little under, to run all 100 of those work items. Everything completed, you can see here that we've had 8 failures out of that set of 100 work items. So I can go ahead and, just like you saw before, I can click on those work items on that failure, and I can see what the failure type was. So in this case, all of them are showing as a business failure, and they're showing that these addresses are invalid. So what we're asking the business user to do in this case is update in Salesforce and then rerun. So that would, just like you saw earlier, where I could, change the data inside of the work data. Whenever that user has corrected the data in Salesforce, they would do just like previously I showed you. You click here and just click retry the one failed item, or you can select multiple and retry just those items. So that's how we would handle failures here.
Right.
And so, yeah, so like I said, it took about 10 minutes to run all those.
That works for us because the actual data the robot works off of is in Salesforce. The only thing we pass is the case number. So, and another important design principle here is, like, let's say you're working with very confidential information. We do have a SOC 2, we do have HIPAA certification, etc. But if you'd rather keep all your data on-prem, as it were, then all you have to do is do this, where you just pass a case number through the control room, and then none of the actual confidential information makes it to the control room's work data management system.
Yeah, great point. All right, any other questions that we have?
No, but since we have a few minutes, I can chat a little bit about that try accepts that maybe some people noticed and might not have known what they were. That's relatively new. Yeah, you show that, and I'll chat a little bit about it. That's a relatively new feature in Robot Framework 5, which is now available on current version of RPA Framework 15.0.0. The try excepts essentially gives you a similar sort of exception handling as you would have in pure Python. And so we are actually in the process of updating the producer consumer template. So when you currently load the producer consumer template, it's going to say if then else. It's going to have like sort of a if block style. I'm about to work on updating that to use this more try except, where you kind of have a high level try except, and then you catch the different exceptions based on the verbiage of the exception, and then that's how you decide how you want to release it. And that allows you to catch the error in any underlying keyword. Say, you're 5 keywords deep into some very important tiny little piece of the logic, and you say fail because of this. That failure propagates back up, and then your try block catches it, and you write an exception clause that knows what you would have written in the fail, and then you would be able to catch it and release it the right way. Let's see. And so, but obviously that's a newer feature in Robot Framework 5. So this webinar is not really focused on that feature specifically, but you're going to see that in the template when you load it, and it's very powerful. So check it out.
Yeah, and we had a question from someone asking if we're going to share the GitHub repository, and thanks, Eric, for answering that. Just to let everyone know, if you didn't see that question, we will be sharing at the end of this in the next couple of days. We'll be sharing this this video to everyone, as well as the links to the slide deck that you saw today, and the GitHub repository links as well. All right. Anything else that we have in Q&A?
Q&A is clear. Whoop. Okay. How can you export errors? Yeah. Yeah.
So any way to
yes.
Go ahead, Blake.
Yes. So you can actually catch the error and assign it a variable in the accept clause. So Tim, if you wouldn't mind, just after any of your accept clauses, on the actual line itself, add a tab and then put the word error message or something there on line 53.
Yeah, let me go ahead and okay.
Oh yeah, spotlight.
So for example, so you would do something like
this part catches the actual error message. This is a string match. You can do things like regex and glob if you want, but default is just straight full string match. And then if you add another tab, you can do, I believe, as in all capitals, AS, and then another tab, and then the variable name. Oh, it corrected your as.
All right, well, let's see if we can get it back. Nope.
It doesn't like you. And then I think convention is like, ERR or E.
Yeah, something like that.
Right. And so that as would need to be in all caps, but for a reason is fighting us. But basically that allows you to reference the actual error message in the accept clause. So then you can do whatever you want with it because it's just code.
Yeah, great point.
We do have a question here. Is there a limit to payloads sent to work items, amount of work items, and their size? Payloads, as in the size of a payload? I mean, I do believe there's a limit, but I don't remember how. It's a lot of characters because it's just it's a JSON. So we'll have to get back to the exact maximum payload size. But I believe there's a maximum number of work items you can push into the API at once, because we don't have the bulk API isn't fully ready yet. So I think it's 100, or we can increase it to 2000.
Yeah, so you're right. So our default is a max output, a max work item output of 100 by default, and a max input of 10 by default. So when I say input, I just mean input work items. So let me just talk about that for just a second. So in our producer side, you can have a maximum of 100 when you say create output work items by default. Like Blake said, we can extend that to higher numbers if necessary based on your case. And then when it comes to the input work items, we have a limit of 10 currently. And what that means is that in this very top line, when I say for each input work item, so one of the arguments that I can add onto here, let me see if I can get back to the actual argument string. There we go. So one of the things I can add onto here is you see I have a keyword that I'm calling, but I can also have this items limit. And so if I have no items limit as my argument here, which just means it's going to take one work item at a time and send it to each available execution environment. Now, if I had made this 10, for example, if I had done something like items limit equals 10, then what that would mean is that it's going to take a batch of 10 work items and send that to an execution environment. So it just depends on kind of your case and if it's necessary, but the max you can do as far as kind of chunking those input work items to send to an execution environment is 10 at a time right now. If you need something higher, let us know. Again, those are just the defaults that you're going to have. Right. Any other questions out there for us?
I am not seeing any. And then I'm gonna,
Right.
oh, here, oh, no. I thought the chat like moved a little bit, but okay, here we go. Can you elaborate more on the limit of producers?
Okay. So when you say limit of producers, do you just mean the limit of work items themselves? Because as far as limits and producers go, it's code. So there really isn't a hard limit on how you create something or what gets what gets put into a work item. It's really just a matter of the number of work items themselves. So when we say 100 work items, so let me try to open up. Let me try to do something live here real quick. Let's try to bring up something. We'll try to open up another file here
Yeah,
for you.
I think there
Go
might
ahead.
be a misunderstanding in the nomenclature here. So
Okay.
the producer, typically you only have one producer that's going to read something and create all the items for the consumer. And the consumer aspect of it is we can only do 100 at this time. I think that's what he was talking about because he says the 100 work items you commented on earlier. So that's the, I guess, explain that one a little bit more or once again, Tim.
Yeah,
Yeah,
and
so what we mean is, and I'm going to go ahead and just try to open up an Excel file here to make this hopefully a little bit more graphical. Um, Apologies, it's taking me just a little while to find it. Here we go. There we go. Okay, so this is the Excel file that I'm creating my work items off of. And so what I'm doing is I'm reading this, and you can see here that I have 100 of these case numbers here. And so when I say work item, what I'm doing is I'm actually taking this particular case number and I'm adding it to a work item. And so that basically each of these rows for me becomes a work item. Um, it's just a JSON body, and we can show you the JSON body if you want to see it. But a work item is just something that is a think about it as an array. If hopefully that makes more sense. So you have an array of 100, and each of those arrays contains data. And so each of those array elements, excuse me, contains data. And so each of those array elements is a work item. And so whatever you stuff in there and send to your consumer side, that's the limit, is just that number of elements in the array. If that makes sense. Now, for example, what I could have done, and let me go back to the slides real quick just to show you this. So in this example that we have here, what we have is that each of these orders is a work item. And you'll notice that this order, for example, contains a name, a zip code, and contains the items being ordered. So in my example, I had just a single case number as the work item, or as the body of the work item. But you can also have more complex work items. So this whole package here is a work item, but um, but it has more data than just a single string. So hopefully that answers the question and makes more sense as to what we mean by a limit of work items. But again, if you need something higher, if you have an issue where you have, I don't know, 500 or 1,000 work items you need to process all at once, just reach out to us and we can help you with that case as well.
Yeah. For example, if you were to try to process more than that, I believe that it just fails to create additional work items at that point. Like the control room just won't do it. And then that's not ideal. So obviously, you know, if you have a bigger workload, let us know. We can help you out with that.
Awesome. Okay.
Okay.
Anything else coming through in chat?
Nope, but we were told that we answered the question, so sweet.
I'm gonna call that a win.
Yeah. Trying to think what else there's to talk about in the work item world. You know, I think an important thing to remember about work items that I've noticed a lot of people that they might not remember is that work item, as Tim was showing, can be very complex. You can have arbitrary data models inside of it. So like, I don't know, maybe do bring up a JSON if you have a work item example, just to, in that like the dev data, you've got like an example.
Okay. I don't have one here, but I can run this and it'll take a very short amount of time.
Okay, cool. I can
So
talk about it.
do this.
So yeah, so theoretically, because it's JSON, you have the ability to use any JSON data model that currently exists, and it's a string. So there's two ways you can actually put arbitrary data into the JSON. You can do this where you've got payload, so the structure of the work item itself is actually more than just what you might see inside the robot. As long as you're using like set work item variable, set work item variables, or set work item file or something like that, or upload a file to the work item. I don't remember the exact keywords, but just don't set the payload directly. There is a keyword for that, but I wouldn't recommend it. But as long as you're using that, it's going to kind of build this structure for you. And so theoretically, you can see you can upload files. So you could upload entire Excel files, you could upload images, you could upload any file. And then you could also base 64 encode things as strings if you really needed to, but much more recommend using the file structure and setting the files directly. And there are APIs for that as well to set them from not robots. Let's see, how to mock work items. Okay, yeah, let's do that. We're showing it right now, kind of, but
yeah, exactly.
Show some more.
Yeah. So yeah, so to your point, Blake, whenever people are yeah, if you're trying to mock up data, it's just JSON. So for example, I've run my producer side, and you can see here I have run one. And this is getting a little bit advanced, but I'll go ahead and show you when you're doing some dev. So if I went ahead and ran this again, and I said run a robot, I went ahead and set producer tasks, you're going to see that I'm going to go ahead and say no input work items, and you're going to see that I'm going to get a run 2 as far as my output work items. So I can create multiple sets of data here. Now these happen to be identical, but I have run 1, I have run 2. And so when I'm deving up my consumer side, so when I'm in here and I'm testing this, and I don't want to rerun my producer and then run my consumer again and again, what I can do is when I go to run, I can hit run robot, select my consumer tasks, and you'll notice that I have now a pop-up because it recognizes that this is a producer consumer model template. And so it'll ask you what input data you want. And so I can choose my run 1 output, or I can choose my run 2 output. And so I can just keep looping through this data again and again and again while I test it. And so if you needed to, for example, right, you could always go in here and you could always make a modification and do something like that if you needed to mock up additional data. But it's just a JSON file, and that JSON file just lives here in this work items output. And so whenever you run your consumer, you just select which work item output you want to run your consumer side on, and that way you don't have to keep running your producer. You can just run your consumer again and again on the same data set until you're getting the results you're looking for.
Yep. And so by default, the get ignore will ignore the work items inside of work items out, but it won't ignore the work items in work items in. So we actually have a cool feature where once you've created your first kind of run 1, and you're like, this is my default set, I want to be able to test this every time. You can actually promote it to work item in, if you don't mind showing Tim. That's the little,
Yeah.
yeah. You push that and you give it a name so that it's recognizable going forward. And then it will become a work item in, and then it will, by default, based on the get ignore from the template, it'll be committable. So then you can have that forever going forward. You can also obviously write raw ones from scratch. So like if you hover over the work items in, Tim, you can click the create new work item. It's in the top right there. It's a little,
yep, there you go.
That guy. Yep. You give it a name and it creates a blank for you to start adding whatever you want. And an important thing to remember is that it's an arbitrary JSON. You can make it whatever you want. You can modify it between runs, between different robots as it passes along from one item to the next. You're not restricted in any way about what your work item looks like or the schema the work item has.
Yeah, great points. Thank you for that. All right. Anything else?
And I guess just as a quick reminder, this is all using the Robocorp code extension in VS Code. Remember, we have two extensions, the Robocorp code and the Robot Framework language server extension. There is another extension with a similar name, has the word IntelliSense in it, that will conflict with our extensions and make things break. So do avoid that extension.
Yeah, good point. Do you have any other questions coming in?
No, it looks like thank yous, and glad we can help show off some of these cool features. I think they're some of my favorite features. And okay, in this example, you use Playwright. Yes.
That is correct. Yep, I do use Playwright. So I can just go ahead and show the conda.yaml. So I am using the Playwright here. And you can also see it in the code itself in the consumer side, right? We have our Playwright library here. So, yep. And you could, if you wanted to, you could modify this example to not use Playwright and to use Selenium. I just chose to use Playwright on this one. It's arbitrary which one you use.
I mean, I always recommend Playwright because I think it's got a lot of built-in features for you. But Selenium is obviously the bigger market share out there.
Yeah, absolutely.
Was there a question? I see in the chat that it was just a reference to what we were using. And Playwright have any version? Playwright does have some versions. You can see in the conda.yaml that he's currently on 12.4.0. That's a project called Robot Framework-Browser. It is an upstream project from us. We do not directly own that implementation. So you can dig through our docs to find the higher level project that we're pulling from. That is, I think, owned by an organization called Market Square. Yeah, it's available on the PyPy. You can link through it if you if you search PyPy for Robot Framework-Browser and then click through to that to the GitHub, you can get there.
Anything else coming through? All right. Well, if there's nothing else coming through, I guess we'll go ahead and wrap up this webinar. So we've shown you how to take an existing robot and modify it to take advantage of the producer consumer template. I'd like to thank everyone so much for joining us today, and good luck automating the boring stuff. Thank you.